This video will serve as a demonstration of Vedebug alongside its ICSI demo paper. Vedebug is a time travel regression debugger for Java with video player-like features. We will begin by showing how to set up and run Vedebug's Java agent with an example test from Google's Guava library. We have already cloned Guava, isolated the tests we want to execute, checked out a certain commit, and added the necessary lines to its pom.xml file to run Vedebug. Due to Guava's structure, we had to change two of its pom.xml files. In the Guava tests pom, we just commented out the Surefire plugin. Meanwhile, in the root pom, we passed the Java agent through Maven's argline property, and to limit the scope of the trace we capture, we also included the specific package which we want to instrument, denoted with the $P. Next, we will build Guava and run that specific test that we want to run using Maven. Anytime a project is run with Vedebug, a hidden directory is created. Guava's project structure causes this directory to be created in Guava tests rather than the project's root directory. Here it is, called .vedebug. Here are all of the files which were created by the Vedebug Java agent during the test's execution. Next, the Python trace completion script must be run. This script takes a .vedebug directory and a source directory as arguments and compiles the completed trace into a single video script, as well as copying a snapshot of the source into the .vedebug directory. This snapshot is what the visualizer uses to display the trace through the execution. I have the Python script's location aliased to trc. First, I will return to the project root directory. Now we can run the visualization. This program is a compiled C executable which takes the location of a .vedebug directory which has already had its trace completed. I have the location of the executable aliased to VDB. The list of controls can be shown by entering Control-H. The visualizer has the same capabilities as many other interactive debuggers, including stepping, stepping over, stepping into the next function, and such. As Vedebug is a time travel debugger, all these features are available in reverse as well. Vedebug can also be interfaced with as a video. Simply playing through the execution forward or backward with the ability to vary the playback speed or pause at any time. Users can also search for the next or previous statement where the control flow of the program exists in a specific function. Now I will demonstrate the regression debugging functionality of Vedebug. As you can see here, I've already moved the original .vedebug directory and renamed it to unbroken. I also checked out a different commit from Guava where the test that we ran earlier fails, moved that directory, and renamed it to broken. To use the regression functionality, you must first run the trace completion script on the new trace, which I did off camera. Then, you run the same script, however this time you give a third argument, which is the directory containing the completed trace which you want to compare to. For this run, the source argument can be the copied version of the source, which is inside of the completed trace directory which you want to view. This is information about the differences between the two traces, such as where they diverge and later reconverge. Now, to visualize the regression, you run the visualizer just like before on the trace directory that you want to see, like so. As you can see in the controls, there are shortcuts to go to the next divergence point as well as the previous one. By just hitting D, I can jump directly to the first point where the two traces diverge. This also works to jump to a reconvergence point. Likewise, I can press R to jump to the previous divergence or reconvergence point. You can see that it can go in both directions here.